Welcome to another Stair Math video. We're going to be working through this worksheet here that many of you will encounter at your time in school. And we're going to work through all the different measurements that we're supposed to find, including the X, Y, and Z measurements. So whenever I get started on a set of straight stairs or really any stairs is a few different things. So first, we want to look at what we even have. All dimensions as shown. Cool. So we have dimensions that are given to us. Desired rise is 170. That's important. And we're using a proportion rule of unit rise plus unit run equals 430. We'll use that to find out our unit of run later. This proportioning rule, there are all sorts of guidelines. Basically, they are to say that if we add up a unit rise and unit run and we get around 430, it means that the stair is going to be comfortable. It's just a guideline to help us figure out a nice proportion. Let's have a look. So we have some measurements here that make up what I call, or we call the upper floor construction. So from the underside of your drywall to the very top of your finished floor is the upper floor construction. We're going to need that later for our measurement that we call BC to basically find our finished opening. And we'll get there in just a minute. But I like figuring all of these out first, including the total rise. So then we have a little bit of an idea already. So upper floor construction, UFC for short, upper floor construction. We just add everything up. So drywall here is 16 plus the floor joist of 286 plus subfloor of 19 plus finished floor of 15. That makes up the total upper floor construction of this kind of a problem. And that is 336. And this changes with every question. So don't just take that number, but look at the measurements you have, or maybe that number will just be given to you. This number right here, the 1950, should sound familiar. That is the headroom. Now, later, for figuring out the finished opening, we're going to be drawing ourselves a triangle and we'll be comparing numbers and we'll get there. But I call them A, B, and C. So for our BC measurement, which is our upper floor construction and headroom, we literally just add them together. So our upper floor construction of 336 plus 1950 is 2286. So BC equals 2286. And you could definitely do this later once we actually get to the question. These are just easy things that we can do first, that if we lose our brain at some point, we can come back to this and see that we already figured it out. Now, there's something else we can figure out over here. We are coming from top of our finished floor to the underside of the drywall over here. So we can sort out our total rise. So the number that's given to us, 2756, plus our upper floor construction, because that is the same here as it is here. It's the same upper floor. 2756 plus 336 gives us 3092. And all these measurements are in millimeters. So I won't be adding millimeters to any of them. You can safely assume that everything is in millimeters. Okie dokie. That is what we can figure out here so far. So let's actually start. First question is our number of risers. Here, let's make sure you can see that well. Well, number of risers is found by taking our total rise that we just figured out, 3092, divided by our desired rise. And we know that as well. That was 170. Now that we know that, we can just pop in some numbers. So total rise is 3092 divided by desired rise is 170. 3092, I still have it in the calculator. Great, I can just leave it. divided by 170 is 181.19. Well, we can't have 0.19 of a riser, so we're going to round this down to, sorry, it doesn't say 181, it says 18.18. And if you've watched some of my videos, I leave this mistakes in here on purpose. Always double check, right? It doesn't make sense that we have 181 risers. So we can use our logic and smarts to double check. So 18 risers, not 181, obviously. So 18 risers. There you go. And we can pop that in here too, 18 risers. Now, next question is our true rise. And on some of these math sheets, it'll say true rise. I often refer to it as unit rise. They are interchangeable, exactly the same thing. So whatever you're used to, whatever you guys use in class, take that. So we use our total rise, that is still the same, 3092, and divide by the number of risers, right? We know we have 18 risers. Now we want to find out how tall they actually are. So 3092 divided by 18 risers. 3092 divided by 18. 171.78. Cool. I usually keep about 2 decimals during the math for these. Again, check with your instructor, but this gets you pretty accurate results. Okay, so true rise, we can fill that in. 171.78. Wonderful. It's going pretty well so far. How about our number of treads? Well, I like to always put myself a little arrow there because there's always one less tread than risers. So knowing that, we have 18 risers, which means we're going to have 17 treads. Why? Well, if we look at our set of stairs, we start with a riser and we end with a riser, which means we have to have one tread less than risers. Also, if you will 100% come across questions where all these numbers are just given to you without a picture. Even though this worksheet has a picture, I'd encourage you to draw it out exactly how it is. And that's really going to help you visualize it and be able to put it into perspective so that you can see what it is that you have to do that when you just get text as a question. Okie dokie, so number of treads. Over here, we can pop that in, 17. Okay, now our true run or unit run, same thing again, is from our proportioning rule over here, unit rise plus unit run equals 430. And again, it's called a rule, but it's just a guide. So if our unit rise plus unit run is 430, in math, we can always move equations around, right? So we do know our unit rise, but we want to find our unit run. So if we basically subtract the unit rise from this side and move it over here, we end up just with the unit run. So that's why 430 minus your unit rise equals your unit run. I hope that makes a bit of sense. That's kind of just basic math equation moving around. Pretty sure those are the professional terms. So let's pop in some numbers here. 430 is given to us. 430 minus our unit rise, it's right here, 171.78 will get us the unit run. If you have this kind of calculator, this is our unit rise, right? We still have the number in here, so we can just pop in 430 minus, and you see the ANS symbol right here in green, and you see that alpha button. So if I hit alpha first and then hit the equals or the enter button, it's gonna use the answer that was my previous one, which was the unit rise. So I don't have to punch it in twice, which is excellent. 258.22. Perfect. So that is our unit run. And I use these kind of shortcuts just to help myself be a little quicker in some areas, but also less punching into the calculator because that's a place where everybody makes lots of mistakes. So unit run 258.22. Perfect. Wonderful. Let's move on to the next question. Unit of bridge. Well, our unit of bridge is our unit rise and unit run on a right angle triangle, right? And it's the hypotenuse. So if we look here, we have a unit rise and we have a unit run, and the hypotenuse is our unit of bridge. So it's basically a part of our nosing line. That's really all that it is. So how can we figure that out? Well, Pythagorean says we can do a squared plus b squared equals c squared, right? So we can do the same thing here. We can say unit rise squared plus unit run squared equals unit of bridge. And obviously we're going to take the square root, and that's going to get us that number. So let's pop in some numbers. Unit rise, we had 171.78 squared plus unit run, we just found out, 258.22 squared. There we go. And we can punch all of this into the calculator. So we still have our unit run in here. Perfect. So squared plus 171.78 squared. I hit the equals or enter button. And then second function, and the square button gets us the square root. Again, equals 310.14. This is particularly handy when you're doing your layout, right? Real world, doing stairs. So every 310.14, that's where you can make a mark for your layout. So that's just one hypotenuse of one unit rise to unit run triangle. B10.14. Okie dokie. Next, we're going to get to stringer length, and I'm going to show you two ways. The way this math sheet is designed is that it is the unit of bridge times your number of treads. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, which basically gets you to here. I would ask your instructor about this. So if this is the way the worksheet is done and this is the way that they would like you to do it, then go for it. 310.14, that's our unit of bridge, times our number of treads. We know that that's 17, gets us, well, look at that. We still have our unit of bridge number in here. How handy. Times 17. 272.38. This is the number that the worksheet would like you to have. I would argue that your stringer length should be your unit of bridge times the number of risers, because it would include this last space here, because when we make these cuts, we always lose some space here from our stringer. So a more accurate measurement to make sure that you're buying a stringer long enough would be to multiply by the unit of by the number of risers, because it would get you all the way to the bottom of the nosing line where you touch the ground. And that would ensure that the stringer you're buying, the material you're buying, is long enough. So like I said, check with your instructor. That's the way I've always done it, but check with them. So here's the alternative: unit of bridge times number of risers. So 310.14 times 18 3, 10. We're going to go with the first one for this worksheet because that's how they say it should be done on this one. So, but now you have both options and ask which one your instructor would prefer. If there's ever a question of, the total length of your nosing line, it is always multiplied by the number of risers to include your last nosing line here to get all the way to the ground. Okie dokie. Alrighty, so we are getting to, here, look at that. Already pre-wrote that. So smart. Let's get to these X, Y, and Z measurements. This is really just a practice in diagram reading and seeing where your arrow marks or your dimension lines land. So for X here, this line lands at the bottom of this tread to the underside of your subfloor, right? X is all the way up here, maybe hard to see on this piece of paper. So the way we find X, our actual rise or unit rise goes from top of tread to top of tread, right? So this right here is our unit rise of 171.78. So now we just need to see what we have to add and subtract from this number to get X. So let's have a look. So top of tread to top of tread. If we start at the bottom here, we have our actual unit rise and we need to add 1 tread thickness. And we know that thickness from here, it says 25. So I'll write 25 in there. Sorry if that's hard to see. So plus 25 so that we get to the bottom. But we're still at the top here, so we have to subtract a couple of things. And this is the finished floor. And that measurement is given to us too of the 15 and our subfloor of 19. And that's exactly what it is, our actual rise or unit rise, plus our tread thickness below 25 till we get to the bottom or the underside of that tread, minus our finished floor from the top here, and make sure that you take the measurement of your upper floor because often the upper and lower floor might be different. So make sure you take the right measurement. So minus 15 gets us to here, minus our subfloor gets us to the underside of the whole situation up there. And that's how it is. So let's pop in some numbers. Our rise, 171.78, plus our tread thickness down here, 25, minus our upper finished floor, that's the top layer, 15, minus our subfloor here to get us to the underside is 19. And then we just get to punch it into the calculator. 171.78 plus 25 minus 15 minus 19. 162.78. Yeah, does that make sense? So we just need to really check where the dimension lines point to and then see what we have. So here we have a unit rise, for example, and then we just need to add and subtract from that original measurement to get to the one that we're actually looking for. And that's the way she goes for all of them. So X we can pop in 162.78. Wonderful. Then we have a couple more left. The next one is Y. Y. Okay, so where is this? Y is also up, oopsie, sorry, up here. This is a stringer measurement. If we were to cut this kind of bird's mouth out in the real world when we're building a set of stairs. So what numbers do we have here? Well, this kind of lands in the middle, of a unit rise. So unit rise probably isn't the easiest one to go with. But what else do we have? So let's see where this lines up. And it looks like it lines up with the bottom of the floor joist. And up here, the X also goes to the top of the floor joist. So underside of subfloor or top of floor joist. Well, do we know our floor joist measurement? Well, yes, we do. Right up there, 286 is from the bottom to the underside. So now let's see where X and Y meet. X went to the underside of our tread here on that first tread, and Y also goes to that same spot. So it makes sense that we take our floor joist depth or width, whatever you prefer, minus our X measurement that we just found out. And that's it. So here we get to do the same thing. Look, we still have the number here. So let's pop in the 286 for our floor joist depth minus alpha and enter button gets us to use the answer that we just had in the calculator. And this is our Y measurement. There you go. 123.22. Yes, that makes sense. So we take our floor joist measurement because that's where our arrows point to from X and Y. That's the measurement we know. And our X and Y measurement measures to the same spot. So we can take our floor joist minus our X measurement, and then we're left with that Y measurement at the bottom. Super duper. Now we have one more, Z. Z is at the very bottom of the stair. So let's see what we can find out here. It's going to be our unit rise minus our tread thickness plus our lower finished floor. So let's see. Our unit rise goes from finished floor to tread or top of tread to top of tread. So this right here is our unit rise, 171.78. Our tread right here, we know what that is. That's 25. And do we know our floor thickness? Yes, we do right here. It's the 18. It's not much space to write in there. So we'll put it right here. So again, so our Z measurement goes to the bottom, the underside of our finished floor, and it goes to the underside of our tread. Our unit rise goes from the top of the floor to the top of the tread. So let's see. So if we start with our unit rise, 171.78, and we subtract our tread thickness, that gets us to here, right? To where the Z arrow is pointing at. So minus 25 for our tread thickness. And it goes to the underside of the floor, so we have to add the floor. Let's see what that comes out to. 171.78 minus 25 plus 18. 164.78. And that is Z. Okay, so one more time. It's our unit rise minus our tread, because the arrow points to the underside of the tread, to the underside of the floor. So we have to add the floor to that measurement because our unit rise goes to the top of that floor. Okie dokie. So that is Z, 164.78. Lovely. Let's look at our finished opening. So the question really is asking, what is our rough opening? But to find that first we have to find our finished opening. So this is the whole A, B, C situation that we were talking about before. So A, B, and C, if you check, creates a triangle. A, B, and this is our part of our nosing line, right? An A, B, and B, C triangle. Well, we have that same triangle with our unit rise and unit run. Do you see how they look similar or the same, really? They're just smaller. We have our unit rise and we have our unit run. And because it's all part of the same stair problem, all the angles are the exact same. So our unit rise in the big ABBC triangle is BC. And this is the number that we figured out before. It's from B at the very top of our upper floor construction to the nosing line. So to find BC, we added our upper floor construction to our headroom to get this measurement. Now our finished floor, or I'm sorry, not finished floor, finished opening is AB, goes from A to B. And AB, or finished opening, same thing, is exactly in relation to our unit run. So what we can do is use ratio and proportion to find out our AB number, our finished opening. So then it goes like this. It goes unit rise over unit run equals BC over AB. And you'll see that this is a vertical measurement over the horizontal measurement, a rise and a run. I always go rise over run. Same with roofs. It just keeps everything straight. So let's see what kind of numbers we have. Whenever you do ratio and proportion, we must have three numbers and we're just looking for the fourth. So let's see. We know our unit rise, 171.78 over unit run. We had that figured out too. 258.22 equals BC we know. We already figured that out. 2286. And AB, or finished opening, however you want to say it, is what we're trying to find. So now we can punch it into the calculator. Cross multiply and divide, right? Like regular. 258.22 times 2286 equals, don't really care about this number, divide it by 171.78 gets us 3436. It's probably the only number that I don't give decimals to because, well, we're talking about 3.4 meters. It's fine if we're half a mil above or below. It's not going to be that different. Okay, so this is our finished opening, or A, B. Yeah, so we're just comparing our small unit rise and unit run triangle to our big BC to AB triangle. And this BC measurement, sometimes people call it drop to line of flight. So DTLF. Depends on verbiage, it's all the same, literally. Just different words to what your instructor might use. Okie dokie. Well, that gives us the finished opening. How about the rough opening? If you think about it, the finished opening is from the inside of your nosing to, the inside of your drywall. But when we go to frame out our stairs, if we make it to the size of the finished opening, our headroom requirement isn't going to work because it's going to be too small. And if we deal with the headroom minimum, then we might get in trouble with the inspector. So to find our rough opening, the number that we use to frame, we add up our finishes. Sometimes the finishes like headroom or header attachments plus nosing and whatever header attachments over here will be given to you. And then you add those. If they're not given to you, you can assume 75 mils or 3 inches. That should be more than enough to cover all those finishes. And at the end of the day, if we end up with more headroom or a slightly bigger opening, nobody cares. Okay, so let's pop in these numbers. Finished opening, 34, 36. I changed colors. Plus our finishes, 34, 36 is still in here, plus 75 gets us 35, 11. for our RO, which is our rough opening. Pop that in here, 3511. And that should be it. Yeah, so just work through step by step, draw everything out as much as you can. And then from there, you just keep your head together and you can logic your way through. And yeah, keep that going all the way around. I hope this is helpful, and I'll see you for the next one.